66.
Hey guys. It is it's Unit 5, Segment 3, Karyotypes. Karyotype is a picture of the chromosomes inside a cell. Did you know that you can snag a cell from your body, and especially one that is just about ready to divide or is beginning to divide, maybe say metaphase in the middle, you can snag that cell and you can, with a computer's help, line up all the chromosomes, matching the bands and matching where the centromeres are, where they connect, and you can get a picture of your 46 chromosomes. And that is called a karyotype. So there it is right there. This is got it all set up in the pairs. You have 23 pairs, and the what a benefit of this is that you can see if there's a chromosomal mutation. A couple of vocab words. First of all, human bodies have 23 chromosome pairs in their cells, 46 total. One of those pairs is going to determine the sex of the individual. Those are called sex chromosomes. And for females, it's an XX, and for male, it's an XY. Each male and female get an X, and then the male gets a Y instead of another X. 22 other pairs are called autosomes, and those are going to code for everything else about you. So back to the sex chromosomes, those are going to code for you being female and for you being male. So any of the maleness or any of the femaleness, those are going to be coded by genes that are found on those sex chromosomes. The 22 other pairs are called autosomes, and those are going to code for everything else, you guys. Karyotypes look like this. Now this is an actual karyotype. The one I showed you on the couple slides before was more computer picture, but this is the actual what it looks like. And they line them up, like I said, by centromeres, so you can kind of see where the centromeres are. Some of them are not directly in the middle, some of them are toward one end or toward the other end. And you can see that they line them up according to size as well. So it goes from longest to shortest. And these are lined up in pairs. Notice over here, this is a karyotype. This side of the screen is a karyotype for an individual. What is the sex of this individual? Notice how there's two X's. If you said female, you are right. Over here we have another karyotype of another individual, and you can see the chromosomes are lined up. These are homologous pairs, okay? They have not grown their other legs, so they don't look like full chromosomes, by the way. These are just more like chromatids, even though we do call them chromosomes. But look at the sex chromosomes here. Right? We have an X and we have a Y, and the Y chromosome is smaller. So this is a male. And then the rest of the 22 pairs, those are going to code for everything else about that person. But these two chromosomes right here are going to code for maleness for that individual. Now this is also, because karyotypes are used to identify genetic disorders, specifically chromosomal disorders, you're going to see some examples of those disorders in the internet investigation that you guys are going to do. So look at this karyotype, see if you can find it. Find the error. Look at it. Look at it. There's an extra chromosome hiding in there. Every pair should have two, one from mom, one from dad. We know where those pairs come from. And boom, right here. Number 13, chromosome 13, there's an extra one. So either the sperm or the egg, when they connected initially to make this individual that carries this karyotype, when the sperm and the egg got together, there were not 46 chromosomes, there were 47. So this number 13 over here, either it happened in one of the divisions, either the meiosis 1 or the meiosis 2 division. So it didn't actually divide maybe the pairs, or it didn't actually divide the actual chromosome. Something happened to create the fact that there's 3 chromosomes rather than 2. And what does this do to an individual? It just depends on which number of chromosome there's an extra one, or maybe they're missing one. And it depends on the genes that are coded, you know, the traits that are coded on that particular chromosome. For this particular one, this is trisomy 13. Very, very rare. I think one in 5,000 offspring have this. And you guys, they won't make it. This individual will not make it past year 1 of their life. So this is pretty important stuff that this chromosome codes for. Sometimes cleft lip is a result of this. Sometimes major organs are not going to function correctly. This individual is going to really struggle to maintain life just because of this one extra chromosome. This is another one. See if you can find the issue. Sometimes the extra chromosome or the missing chromosome is detrimental to life. Like this could result, these kinds of things can result in a miscarriage or whatever. But sometimes they're not. Sometimes people can be born and function and live out a great life. And this is an example of one. Right here's your extra chromosome. This is the trisomy 21, meaning that there's 3 chromosomes on the 21st. And this is Down syndrome. And people can go through life just fine and dandy with this syndrome. So, and there's other ones too. There's where you have 3 X's, right? This is a female, by the way, and sometimes trisomy can happen on the X chromosome. We have 3. Sometimes it can happen, on any of those numbers, and it just depends on what kind of genetic coding happens on those chromosomes. So this is nice to be able to identify any kind of disorders that are happening, and in particular, pregnant women, that would like to know if their baby, if the woman is older, there's a higher risk of trisomy. If it's in her genetic background or his genetic background, the father's genetic background, there might be an interest to get a karyotype done. Typically, people don't do them, but there has to be a reason why, because there's a risk to go in and collect the infant growing baby's cells inside the body. So, but it's kind of neat. Later on in future units, we'll talk about gene disorders, which you cannot see on this. You can't see the specific genes here. So the only thing you can see with a karyotype is chromosomes and chromosomal disorders. And that's it, guys.